December 17, 1944, 6:30 in the morning, Bastogne, Belgium. Oberst Friedrich von Lüttwitz stood among the captured American fuel depot with disbelief etched across his weathered face. Stacked before him were thousands of jerry cans containing high-octane gasoline, more fuel than his entire Panzer regiment had seen in the past 6 months combined. Herr Oberst called his aide, Major Klaus Richter, running calculations on captured manifests. The Americans abandoned over 200,000 liters of fuel at this depot alone. This single supply point contains more gasoline than Army Group B receives in a week. Von Lüttwitz picked up one of the American fuel containers, noting its quality construction and the clear, high-grade gasoline within. While his panzers had been running on synthetic fuel mixed with wood alcohol that damaged their engines, the Americans were using premium fuel that his mechanics could only dream of accessing. What Oberst von Lüttwitz had discovered was not just a fuel depot, but evidence of American logistical superiority so complete it rendered German resistance mathematically hopeless. The Ardennes Offensive had been planned around capturing exactly these kinds of American supplies. But the abundance he witnessed revealed the futility of German strategic thinking. The mathematics of abundance were written in every fuel drum and supply manifest. While German forces planned operations around fuel shortages measured in liters, Americans conducted warfare with fuel measured in millions of gallons. The logistics gap had become insurmountable. What began as German hope that captured American supplies would sustain their offensive would evolve into shocked recognition that they faced an enemy whose logistical capabilities exceeded German comprehension. The colonel who captured American fuel was witnessing the industrial foundation of inevitable defeat. The German fuel crisis of 1944 represented the culmination of strategic miscalculations that had plagued German military planning since the war's beginning. By December 1944, fuel shortages had become the decisive limitation on German military operations across all fronts. German synthetic fuel production, which had never exceeded domestic requirements even at peak capacity, had been systematically destroyed by Allied bombing campaigns. The loss of Romanian oil fields in August 1944 eliminated Germany's last major natural fuel source, leaving German forces dependent on rapidly depleting strategic reserves. The statistical reality was catastrophic. German fuel allocation for December 1944 totaled 4.2 million gallons for all military operations. American forces in Europe were consuming 12 million gallons daily while receiving 14 million gallons through their supply systems. They were accumulating reserves while fighting a global war. General Heinz Guderian, chief of the German General Staff, had warned Hitler in November 1944 that fuel shortages made major offensive operations impossible. His staff calculations showed that the Ardennes Offensive would require 6 million gallons of fuel to reach Antwerp, but German fuel allocation provided only 2 million gallons for the entire operation. "We are attempting mechanized warfare with horse-drawn logistics," Guderian told Hitler during final planning session. "American industrial capacity provides our enemies with unlimited fuel while we measure our supplies and emergency reserves. This offensive will fail due to fuel shortages before it achieves strategic objectives." Hitler dismissed Guderian's warnings, insisting that German forces would capture American fuel depots to sustain their advance. This plan represented desperate hope rather than realistic strategy, betting Germany's last reserves on capturing enemy supplies that might not exist in sufficient quantities. The American fuel supply system that supported Allied operations in Europe represented logistical achievement that exceeded German planning assumptions by orders of magnitude. The Red Ball Express alone delivered more fuel daily than total German fuel allocation for the entire Ardennes Offensive. American fuel logistics began with crude oil production that dwarfed German synthetic fuel capabilities. The United States domestic oil production in 1944 totaled 1.8 billion barrels. While German synthetic fuel production managed 33 million barrels, including all occupied territories. The production ratio favored America by 50-1. Refining capacity demonstrated similar disparity. American refineries processed petroleum products at rates that exceeded total German fuel requirements while simultaneously supplying global military operations and maintaining domestic consumption. German synthetic fuel plants operated at fractions of design capacity due to bombing and resource shortage. Transportation infrastructure supporting American fuel distribution included pipelines, specialized tanker vessels, and motor transport fleets that exceeded German capabilities across all categories. The pipeline under the ocean delivered 1 million gallons daily from Britain to France, more than total German synthetic fuel production. Storage and distribution facilities at American bases contained fuel reserves that exceeded German strategic stockpiles. Individual American supply depots held more gasoline than entire German army groups received monthly. The abundance reflected industrial capacity beyond German comprehension. Oberst von Lüttwitz had participated in the initial planning sessions for the Ardennes, Offensive at Ziegenberg Castle in November 1944. Field Marshal Gerd von Rundstedt had presented the operation as Germany's last chance to achieve strategic victory in the West through decisive offensive action. The plan required German forces to advance 65 miles through difficult terrain to capture Antwerp, splitting Allied armies and forcing negotiated settlement. Success depended on maintaining rapid advance schedules that would prevent Allied forces from organizing effective counterattacks or defensive positions. Fuel calculations for the operation showed that German forces would consume their allocated supplies before reaching intermediate objectives, requiring capture of American fuel depots to continue operation. Intelligence estimates suggested sufficient American fuel existed at supply bases throughout the Ardennes region. The Americans maintained supply depots at every crossroads, reported Colonel Oskar Koch, German intelligence officer responsible for Allied logistics analysis. Capturing these facilities will provide fuel necessary to reach Antwerp, while simultaneously depriving enemies of resources needed for counter-operation. This assessment proved both accurate and irrelevant. American fuel abundance existed as reported, but German logistics could not effectively utilize captured supplies due to transportation and distribution limitations that intelligence had not adequately assessed. The opening phase of the Ardennes Offensive demonstrated German fuel shortages within hours of initial attacks. Panzer formations advanced using emergency fuel reserves while counting on captured American supplies to continue operations beyond the first day of fighting. Kampfrupp Piper, spearheading the 1st SS Panzer Army advance, consumed 40% of allocated fuel during the first 12 hours of operation. SS Oberstverband Joachim Piper reported that his column would require captured American fuel by the second day to maintain operational capability. German forces discovered abandoned American equipment and supply dumps beginning December 16th, but fuel shortages prevented effective exploitation of captured materials. Tanks ran out of fuel before reaching known American supply locations, while captured supplies could not be distributed to units requiring immediate resupply. The irony was crushing. German forces could see American abundance but lacked fuel to reach it. Supply columns carrying captured American gasoline to German units consumed more fuel during distribution than they delivered, creating negative logistics that accelerated German fuel depletion. Von Lüttwitz's discovery of the Bastogne fuel depot occurred during the brief German occupation of supply routes leading to the besieged American garrison. His reconnaissance battalion had advanced beyond their supply lines using fuel captured from abandoned American vehicles encountered during the advance. The depot contained fuel storage that exceeded German regimental allocation by substantial margin. Thousands of jerry cans, hundreds of fuel drums, and multiple fuel trucks represented gasoline reserves that German forces had not seen concentrated in single locations since early war period. Quality analysis revealed that American fuel exceeded German specifications across all categories. High-octane aviation gasoline, premium motor fuel, and specialized lubricants demonstrated American access to petroleum products that German synthetic fuel could not replicate despite years of research and development. This fuel is superior to anything our industry produces, reported Major Richter after examining fuel samples. American gasoline tests at 100 plus octane, while our best synthetic fuel achieves 74 octane. Their standard motor fuel exceeds our aviation gasoline quality. The implications were staggering. American vehicles operated using fuel that enhanced performance, while German equipment suffered reduced capability due to poor quality synthetic alternatives. Mechanical advantage compounded logistical superiority to create overwhelming operational disparities. German attempts to utilize captured American fuel revealed distribution problems that American logistics had solved systematically. Moving fuel from capture points to operational units required transportation assets that German forces could not spare from primary missions. Fuel trucks capable of transporting captured gasoline were needed for ammunition resupply, casualty evacuation, and command communication. German logistics lacked redundancy necessary for exploiting captured supplies while maintaining essential support functions. Distribution distances exceeded German transportation capability under combat conditions. Fuel captured at forward positions required transport through contested areas where Allied air attacks and artillery fire destroyed supply convoys attempting to move captured materials. The time required for processing and distributing captured fuel exceeded operational requirements for maintaining offensive momentum. German forces needed immediate fuel resupply to continue operations, but captured supplies required hours or days for effective distribution. Security requirements for protecting captured fuel from Allied recapture or destruction consumed personnel and resources needed for offensive operations. Guarding supply depots prevented optimal utilization of limited German forces for primary tactical missions. Von Lüttwitz's analysis of captured American documentation revealed logistical planning that exceeded German organizational capability by substantial margins. Supply manifests, distribution schedules, and inventory records demonstrated systematic approaches to logistics management. American fuel allocation documents showed individual units receiving weekly fuel deliveries that exceeded monthly allocations for comparable German formations. The abundance reflected planning assumptions about fuel availability that German logistics could not accommodate. Maintenance schedules for American vehicles assumed unlimited fuel availability for testing, training, and routine operation. German maintenance procedures emphasized fuel conservation that reduced equipment reliability and operational effectiveness. Training documentation revealed that American personnel received instruction in fuel handling, storage, and distribution that exceeded German technical training in comparable specialties. Systematic education produced logistical expertise that multiplied American supply effectiveness. Operational planning documents demonstrated that American commanders designed missions assuming adequate fuel supplies, while German planning began with fuel limitations that constrained operational possibility. Strategic thinking reflected resource availability that determined tactical options. The psychological impact of witnessing American fuel abundance proved as significant as tactical implications for German forces involved in the Ardennes operation. Soldiers who had experienced months of fuel shortages encountered evidence of enemy abundance that exceeded their comprehension. Tank crews discovered American fuel quality that eliminated engine problems plaguing German equipment using synthetic alternatives. Running captured American gasoline. German vehicles achieved performance levels not experienced since early war periods when natural fuel remained available. Maintenance personnel examining captured American equipment found fuel systems designed for continuous operation rather than conservation-based usage patterns. American vehicles assumed fuel availability that German logistics could not provide under any operational circumstances. Supply officers calculating distribution requirements for captured fuel recognized that American depot contained more gasoline than their units would receive through normal allocation during the entire offensive. Single American supply point exceeded German logistical planning assumptions. Command personnel reviewing captured American logistics documentation understood that fuel shortage represented fundamental German disadvantage that could not be overcome through tactical or strategic innovation. Logistical inferiority rendered German resistance ultimately hopeless. The strategic implications of American fuel abundance extended beyond immediate tactical considerations to fundamental questions about German ability to continue mechanized warfare against opponents possessing unlimited logistical resources. German offensive operations required fuel allocation that exceeded available supplies even when supplemented by captured American resources. The mathematics of consumption versus availability rendered sustained offensive action impossible under existing logistical constraints. Defensive operations designed to preserve German fuel for critical situations still required mobility that available supplies could not support. Stationary defense eliminated German tactical advantages while failing to solve fundamental resource problems. Alternative strategic approaches emphasizing non-mechanized warfare contradicted German military doctrine and organizational structure developed around mobile operations. Changing strategic philosophy required resources and time that German position no longer permitted. Negotiated settlement options required bargaining positions that fuel shortages had eliminated through reduced German military capability. Logistical weakness undermined diplomatic alternatives by demonstrating German inability to sustain continued resistance. The industrial analysis supporting American fuel abundance revealed manufacturing capabilities that exceeded German production across all categories of war material. Fuel production statistics provided insight into broader American industrial advantages that rendered German competition hopeless. American petroleum refining capacity exceeded total German industrial production when calculated by energy output and economic value. Single American refinery complexes processed more petroleum than entire German synthetic fuel industry managed during peak production period. Transportation infrastructure supporting American fuel distribution demonstrated engineering achievement that exceeded German construction capability under wartime conditions. Pipeline networks, port facilities, and specialized transport equipment represented systematic development beyond German resource capacity. Storage capabilities at American fuel installations exceeded German strategic reserves, while representing only routine operational stockpiles. American logistics assumed abundance that German planning could not accommodate even during peacetime industrial preparation. Quality control procedures ensuring American fuel specifications exceeded German manufacturing standards despite vastly greater production volume. American industry achieved precision and reliability that German synthetic fuel could not duplicate at any production level. The technological analysis of American fuel production revealed research and development capabilities that had surpassed German achievements in petroleum chemistry and synthetic fuel development. American technology had evolved beyond German scientific understanding. Catalytic refining processes produced American fuels with specifications that German synthetic methods could not achieve despite years of research investment. American petroleum chemistry had solved technical problems that German scientists continued to investigate. Additive technology enhanced American fuel performance beyond capabilities of German synthetic alternatives. Chemical engineering achievements provided American forces with operational advantages that German industry could not replicate through available methods. Production efficiency in American fuel manufacturing exceeded German synthetic fuel productivity by margins that reflected systematic advantages in industrial organization and technical capability. American methods achieved superior results through coordinated development. Research programs supporting American fuel development demonstrated scientific resources that exceeded German industrial research across all technical categories. American investment in petroleum technology represented systematic commitment beyond German capability. Von Lüttwitz's final assessment of captured American fuel capabilities, prepared for Army Group B headquarters, acknowledged logistical disparities that rendered continued German resistance strategically meaningless. His report represented professional recognition of insurmountable disadvantages. American fuel abundance exceeds our strategic requirements by factors we cannot calculate, von Lüttwitz wrote in his classified analysis. Individual enemy supply depots contain more gasoline than our forces receive through normal allocation. Industrial capacity producing this abundance renders our resistance futile through systematic resource disadvantage. The report concluded with recommendation that German leadership acknowledge logistical realities that made continued offensive operations impossible while defensive operations remained unsustainable due to fuel limitations that captured American supplies could not remedy. Major Richter's supporting analysis detailed production comparisons that revealed American industrial achievement beyond German comprehension. American fuel production alone exceeded German industrial output across all categories while representing fraction of total American manufacturing capability. Enemy produces more fuel weekly than our industry manufactures annually, Richter reported. Logistics supporting this production demonstrate organizational capabilities beyond our military potential. Technological achievement in fuel quality exceeds our scientific understanding. The strategic recommendations emerging from German fuel analysis acknowledge that continued warfare required resources and capabilities that Germany could not access through military action or industrial development. American advantages had become insurmountable through conventional means. Post-war analysis of German fuel shortages revealed that Hitler's decision to continue the Ardennes Offensive despite fuel limitations represented strategic thinking disconnected from logistical reality. German leadership refused to acknowledge American superiority even when evidence became undeniable. Captured German documents showed that military professionals recognized American logistical advantages while political leadership maintained fantasy beliefs about German technical superiority and American industrial weakness. Professional assessment contradicted ideological commitment to German supremacy. Intelligence analysis accurately described American fuel abundance but failed to influence strategic decision-making because conclusions contradicted Nazi ideology about racial and technological superiority. Military reality was subordinated to political requirements throughout German planning process. Tactical commanders understood fuel limitations that made their missions impossible but received orders that ignored logistical constraints in favor of strategic objectives that resource shortages rendered unachievable. Professional competence was overruled by ideological fantasy. Supply officers calculated resource requirements that exceeded available supplies by substantial margins but were commanded to execute operations regardless of logistical impossibility. Mathematical reality was dismissed when it contradicted political determination. Today, military historians recognize that German fuel shortages during the Ardennes Offensive represented culmination of strategic miscalculations that had characterized German military planning throughout the war. Logistical limitations rendered German tactical excellence irrelevant against enemies possessing systematic resource advantages. Industrial historians acknowledge that American fuel production during the war demonstrated manufacturing capabilities that established the United States as dominant global power through systematic application of industrial capacity to military requirements. Logistics historians credit American fuel distribution systems with representing organizational achievement that enabled Allied victory through superior resource management and systematic supply coordination that exceeded German logistical capabilities. Economic historians recognize that fuel production statistics revealed national industrial disparities that determined strategic outcomes. Regardless of military skill or tactical innovation, resource availability became a decisive factor in military effectiveness. Technology historians acknowledge that American fuel quality and production methods represented systematic engineering achievement that exceeded German scientific development despite German reputation for technical excellence. Industrial capacity translated scientific knowledge into practical advantage. Veterans who participated in fuel capture operations provided testimony about American abundance that impressed German personnel despite wartime hostility. Professional soldiers acknowledged logistical superiority that transcended national or ideological loyalties. Oberst Friedrich von Lüttwitz, surviving the war in Allied captivity, reflected on his recognition of American fuel abundance. "We captured enough gasoline to run our vehicles for weeks. Yet this represented standard American supply depot. Their abundance made our scarcity absolute. We knew then that industrial capacity had determined the war's outcome." German Colonel Friedrich von Lüttwitz captured U.S. fuel during the Ardennes Offensive and knew Germany was doomed because American logistical abundance exceeded German capabilities so completely that continued resistance became strategically meaningless regardless of tactical outcomes. The fuel depot that seemed like salvation to German forces represented routine American supply allocation that demonstrated industrial capacity beyond German comprehension. Recognition of this disparity marked the moment when military professionals acknowledged defeat before political leadership. The American fuel that German forces captured with desperate hope provided conclusive evidence that Germany faced opponents whose resources exceeded German understanding of industrial possibility. Logistical superiority had rendered German military excellence irrelevant. The comparative analysis of fuel consumption patterns revealed fundamental differences between German and American approaches to mechanized warfare that extended beyond mere resource availability to philosophical differences about operational planning and strategic thinking. German fuel consumption calculations emphasized conservation and efficiency that reflected resource limitations rather than tactical optimization. Tank crews received training in fuel-saving techniques that reduced operational effectiveness but preserved limited supplies for critical missions. American fuel consumption patterns emphasized operational effectiveness over conservation, reflecting resource abundance that permitted tactical optimization without logistical constraints. Tank crews operated equipment at peak performance levels that maximized combat effectiveness regardless of fuel consumption rates. The psychological impact of fuel shortage on German military personnel proved as significant as tactical limitations imposed by logistical constraints. Crews who had experienced months of fuel rationing encountered evidence of American abundance that exceeded their comprehension of industrial possibility. Maintenance procedures reflected fuel availability that determined operational philosophy. German mechanics developed techniques for extending equipment life using minimal fuel for testing and adjustment, while American maintenance assumed unlimited fuel for optimal equipment performance. Training programs reflected resource availability that shaped tactical doctrine and operational planning. German training emphasized fuel conservation that reduced pilot and crew proficiency, while American training provided unlimited practice that enhanced operational effectiveness. Strategic planning incorporated fuel limitations that constrained German operational possibilities, while American planning began with assumption of adequate fuel supplies that enabled tactical flexibility and strategic options unavailable to German forces. The technical analysis of captured American fuel revealed chemical composition and refining techniques that exceeded German synthetic fuel technology. Despite years of research investment and development programs designed to achieve petroleum independence, octane ratings and captured American fuel exceeded German aviation gasoline specifications while representing standard motor fuel for American ground vehicles. Quality levels that German industry could not achieve for critical applications were routine for American logistics. Additive chemistry in American fuel provided performance enhancement and engine protection that German synthetic alternatives could not replicate through available manufacturing processes. Chemical engineering achievements demonstrated technological superiority that transcended resource availability. Refining processes that produced American fuel utilized catalytic methods that achieved efficiency and quality beyond German synthetic fuel capability. Petroleum chemistry had evolved beyond German scientific understanding during wartime isolation from international technical development. Storage stability of American fuel demonstrated preservation techniques that prevented degradation during extended storage periods. German synthetic fuel required constant monitoring and treatment to maintain usability over time, creating additional logistical burdens. The logistical infrastructure supporting American fuel distribution demonstrated organizational achievements that exceeded German military capability across all categories of supply management and transportation coordination. Transportation networks delivering American fuel to forward positions included specialized vehicles, pipeline systems, and distribution facilities that represented systematic engineering solutions to logistical problems that German forces addressed through improvised methods. Distribution schedules maintaining American fuel supplies demonstrated planning coordination that ensured continuous availability. Despite intensive consumption and operational demands, German distribution relied on emergency measures that created operational uncertainty. Storage facilities protecting American fuel from weather, contamination, and enemy action represented systematic preparation for sustained operations under adverse conditions. German fuel storage emphasized concealment over protection, creating vulnerability that American methods avoided. Quality control procedures ensuring American fuel specifications remained consistent throughout distribution chain demonstrated systematic attention to performance requirements. German fuel quality varied due to production limitations and distribution constraints. Inventory management systems tracking American fuel consumption and availability provided commanders with accurate information for operational planning. German fuel accounting relied on estimates that proved inaccurate due to communication and recording limitations. The economic analysis of fuel production revealed industrial disparities that extended beyond immediate military applications to fundamental differences in national economic capacity and technological development. Cost analysis comparing American fuel production with German synthetic alternatives revealed efficiency advantages that reflected broader industrial superiority. American petroleum refining achieved superior results at lower resource costs than German synthetic methods. Investment requirements for American fuel infrastructure demonstrated financial capacity that exceeded German economic resources even during peacetime preparation. Capital allocation for petroleum industry represented systematic development beyond German possibility. Employment statistics for American fuel production revealed workforce training and technical expertise that exceeded German industrial capacity. Educational investment producing skilled petroleum workers demonstrated systematic human resource development. Research funding supporting American fuel technology exceeded German investment in synthetic fuel development despite German recognition of petroleum independence as strategic necessity. Scientific resources favored American technological advancement. Manufacturing capacity in American petroleum industry exceeded total German industrial production when measured by energy output and economic value. Single American refinery complexes surpassed entire German synthetic fuel program. The strategic implications of fuel disparities influenced German military planning across all operational categories and tactical considerations, forcing revision of doctrine that had emphasized mobile warfare and mechanized operations. Tactical modifications emphasizing infantry operations and defensive positions reflected fuel limitations that prevented mechanized maneuver warfare. German tactics adapted to resource constraints rather than tactical optimization. Operational planning incorporated fuel shortages as primary limiting factor that determined mission possibilities and strategic objectives. Available fuel determined operational scope rather than tactical requirements or strategic goals. Strategic objectives were revised downward to accommodate fuel limitations that prevented sustained offensive operations or mobile defensive tactics. Resource constraints determined strategy rather than political or military consideration. Alliance relationships were influenced by German inability to provide mechanized support for partner nations due to fuel shortages that limited German military assistance and cooperative operations. Diplomatic initiatives emphasized negotiated solutions that would reduce German fuel requirements through territorial concessions or operational restrictions that acknowledged logistical limitations. The technological development programs attempting to address German fuel shortages demonstrated research efforts that had proven inadequate for solving fundamental resource problems through scientific innovation alone. Synthetic fuel research continued throughout the war despite bombing attacks that destroyed production facilities faster than they could be rebuilt or expanded. Scientific effort could not overcome industrial destruction and resource limitations. Alternative fuel experiments including alcohol, wood, gas, and coal-derived substitutes provided emergency solutions that reduced equipment performance and reliability. Technical alternatives proved inferior to petroleum products in all operational categories. Engine modification programs attempting to operate German equipment using available fuel alternatives achieved limited success while reducing operational effectiveness and mechanical reliability. Engineering solutions could not overcome chemical limitations. Fuel conservation technologies including improved engines, transmission systems, and operational procedures provided marginal improvements that could not address fundamental shortage problems. Technical efficiency could not compensate for absolute resource deficiency. Research cooperation with partner nations and neutral countries attempted to access petroleum resources and refining technology, but diplomatic and military constraints prevented meaningful technological transfer or resource acquisition. The international implications of German fuel shortages influenced Allied strategy and neutral nation policies that recognized German logistical vulnerability as a decisive factor in military capability. Allied targeting priorities emphasized German fuel production and distribution as critical vulnerability that could accelerate German military collapse. Bombing campaigns focused on synthetic fuel plants and transportation infrastructure. Neutral nation policies regarding petroleum trade reflected recognition that German fuel shortages created military weakness that reduced German threat to neutral security. Trade relationships favored Allied requests over German demand. Strategic bombing assessment revealed that attacks on German fuel infrastructure achieved greater impact on German military capability than attacks on aircraft production or other industrial targets. Fuel shortage multiplied effects of all other resource limitations. Intelligence priorities emphasized German fuel situation as an indicator of military capability and strategic planning potential. Fuel shortage provided insight into German operational possibilities and strategic limitations. Diplomatic negotiations incorporated recognition that German fuel shortages created bargaining disadvantages that strengthened Allied negotiating positions. Logistical weakness undermined German diplomatic effectiveness. The social implications of fuel shortages extended beyond military applications to civilian transportation, heating, and industrial production that affected German population morale and government credibility. Civilian fuel rationing eliminated private transportation and reduced heating fuel that created hardship affecting public support for continued warfare. Population suffering undermined government legitimacy and military recruitment. Industrial production limitations due to fuel shortages reduced civilian goods availability and employment opportunities that created economic hardship beyond wartime sacrifice expectation. Resource allocation conflicts affected social stability. Agricultural mechanization declined due to fuel unavailability that reduced food production and created additional civilian hardship. Rural transportation limitations affected food distribution and market access. Urban transportation systems reduced services due to fuel shortages that affected civilian mobility and industrial workforce availability. Social disruption multiplied economic effects of resource limitations. Propaganda effectiveness declined when government claims about military progress were contradicted by visible fuel shortages affecting civilian life. Credibility problems undermined morale and political support. The educational implications of German fuel crises revealed technical training deficiencies that had prevented development of petroleum expertise necessary for achieving fuel independence through domestic resources and technology. Technical education programs had emphasized mechanical engineering over chemical engineering that limited German capability for petroleum refining and synthetic fuel development. Educational priorities had not addressed strategic resource requirements. Scientific training in petroleum chemistry and refining technology lagged behind American and British achievements due to isolation from international scientific cooperation and resource limitations for research programs. Industrial training for petroleum workers remained limited due to German emphasis on synthetic alternatives rather than petroleum refining expertise. Workforce development had not addressed strategic fuel requirements. Research university programs lacked funding and facilities for petroleum science that prevented development of expertise necessary for competitive fuel technology. Academic resources had not supported strategic technological requirements. International scientific cooperation that could have provided petroleum expertise was prevented by wartime isolation and ideological barriers to foreign technical assistance. Educational isolation limited technological development. Today, military historians recognize that German fuel shortages during the Ardennes Offensive represented culmination of strategic resource planning failures that had characterized German military preparation throughout the war period. Logistics historians acknowledge that American fuel abundance demonstrated systematic logistical planning that provided decisive military advantage through superior resource management and industrial coordination that exceeded German organizational capability. Economic historians recognize that fuel production statistics revealed industrial disparities that determined strategic outcome, regardless of tactical innovation or military leadership quality. Resource availability became a decisive factor in military effectiveness. Industrial historians credit American petroleum industry with representing systematic technological achievement that established the United States as dominant industrial power through coordinated development of resource extraction, refining, and distribution capabilities. Technology historians acknowledge that German synthetic fuel research, despite scientific achievement, could not overcome fundamental resource limitations and industrial destruction that prevented practical application of research results to strategic requirements.